Okay, so we done this answer. You can see the slide, everyone. Okay, next question. Okay, your choice now. Your turn.
Yes.
Give a try. Question 1. What's the answer? A parachutist is falling in air and is accelerating. What are the forces acting on him? So what is that? Weight, air resistance, and upthrust, of course. Say the force acting on him in ascending order. So is accelerating. The parachute is falling in air and is accelerating downwards. So upthrust, the state the force acting on him. Say the force acting on him in ascending order, going up. Okay. So weight is the greatest, air resistance is the second, upthrust is the lowest for the air. For the oil, of course, the same question as the first one. A steel ball is falling down in oil. So in this case, the weight is, of course, again the dominant, but upthrust will take the second place because density is higher. Okay. Okay, so be careful. And oil, the order is different, ascending order. Weight is the dominant, but upthrust will be the lowest in air. Drag force will be the lowest in oil. Okay. Okay, so that's about forces. Okay, 3 main forces you have to know in depth is what? Upthrust, air resistance, upthrust, air resistance, and friction. Okay, what is the difference between friction and air resistance? Anyone? What is the only difference between friction and air resistance? Anyone?
Air resistance is the whole body, not the one touching.
Air resistance. Better answer. One difference between friction and air resistance. Anyone? I think I already told you that earlier. I told you the what do you call the properties for just now. You can check the properties. What is the difference? Main difference between friction and air resistance? Friction.
Friction affected by roughness, but
okay. Yeah, that's one. Okay, correct. Another one, speed. Friction unaffected by speed. Air resistance affected by speed. Okay, what is the similarity for both of them? What is the similarity of both forces, friction and air resistance? Anyone? What is the similarity?
Affected by mass.
Both affected by mass. Okay. Okay. Any other answer? Both opposes. Very good. Both opposes. Both opposes movement. Good. Okay. Okay. So that's about the first part. Okay. So type of force is done. So next we talk about equilibrium of forces. Okay. So you learned this before, equilibrium. When an object is in equilibrium, what is the condition the object must have? If an object is said to be equilibrium, means what must be zero? The net force must be zero. When all forces which act upon a balance, the object is said to be in equilibrium, balance force law. So the object is in equilibrium means force to the right, force to the left, up, down must be same. Then the system must be in equilibrium. Equilibrium means it must be in rest or move with constant velocity. Also said to be equilibrium. Okay. So 3 forces acts on a mass, F1 and F2 and F3. Okay. If the mass is in equilibrium, these 3 forces will form a triangle. We've done this before in the early topics. So you must know how to join them one after another. Okay. So when you join them, you do vector addition or vector subtraction to find what you call net force. Should be vector addition. So one force you must connect the other. Okay. So the first force, always take the horizontal one or the vertical one first. Then we connect the second one, maybe and the third one here. Okay. So head of the first vector connected to the tail of the second vector. Okay, and so on connected. It will make a closed triangle. From the beginning to the end is your net force, but here because it's a close up, net force is 0. So we say it's in equilibrium. So equilibrium make a closed triangle, a polygon. Okay. So tug of war. So all of them pulling the center, but it's in equilibrium. So all the 4 forces in all directions, the net force must be 0. So if all the forces you connected one after another, it must make a closed polygon. Okay. Your syllabus only triangle normally goes for 3 forces only. Okay. Okay. So now let me temporarily go to your Word file. Okay. This file is your Word file. So here we're done with the type of forces already. Now we are talking about equilibrium. Okay. So this all are concise notes. So later, I want you to fill up this answer for these 3 questions, which we already discussed this. Okay, discussion, what caused by upthrust, upthrust significant the and why, derive the formula. I want you to do this in this paper, okay, in the empty space as homework. Okay, now what I want to do is this part, equilibrium. Okay, I already told you that an object is said to be equilibrium if the resultant force is 0. If you have 3 forces, if you connect them one after another, it must make a closed triangle. Okay, in this slide, I say draw the vector diagram for the forces below. Okay, there are no diagram provided here. Okay, let me provide the diagram to you. Okay, the first diagram you have to draw is this. No, it takes time. Okay. The first diagram I want to draw, show all the forces acting on this system. The first system is inclined surface. An object is on this surface, and the object is in rest. The object is in rest. Please write all the forces acting on this. This is 30 degrees, let's say, theta 30 degrees. Okay. So show all the forces acting on this system. Okay, let's we do together. The first force is, of course, the weight, mg. Mg, you must show from the center. You can't show down, you can't show up, must be at the center. Because why? Mass always, weight always act through the center of gravity. Center of gravity. Okay, second force, normal. Okay, normal should act from the surface at the bottom. So you have to drag from the surface from here to up. Is your normal force. Then that force is friction. Friction you must show from the surface here. Friction. Okay, these are the 3 forces it's supposed to draw. Weight must act from the center. Normal force must act from the surface, and the friction also between the surface going up here. Okay. If it's this in equilibrium, can you draw the vector triangle in equilibrium with the proper internal angle for 30 degrees? Okay, which force you take to draw the vector triangle? First, use the force which is either perfectly horizontal or perfectly vertical first to start to draw. So I think my choice is weight. Okay, so I draw the weight first, weight acting down. Okay, mg. Then I start to connect one of the force here. Maybe I take the friction. So I put the friction here. But now, then the third one, normal force. Normal force here. Okay, where's your 90 degrees? 90 degrees between the friction and the normal force one. Okay, normal force here is normal force here, friction and normal force. Friction is here, and normal force is 90 degrees, right? Friction and normal force. So this will be 90 degrees. Friction, like you can draw the friction here, friction this way, and normal force up. Friction this way, normal force up. So this is 90 degrees. So where's your 30? 30 is the 1 or the 2? 30. Anyone? 30 will be the angle 1 or angle 2? 30 degrees.
2.
30 degrees is the angle between what? Normal force is going like this. Mg is acting down. So normal force up. Mg is down. So 1 or 2?
2.
2. Yes. 2 is 30 degrees. 2 is 30 degrees. This will be 60 degrees. Okay. So this is the triangle you have to draw. Okay. Those before I teach you, you got this good. Okay. So you must know how to draw the vector diagram when a system is in equilibrium. Okay. So in the paper for the first one, where is it? Forces. Yeah. So here you have to draw that triangle. You have to draw the triangle. You have to draw the vector diagram. The triangle, the vector diagram as the number 1. Okay. So you have to draw this. Okay. The second one, there are 2 images needed. The second one is the complex one. The second one I want you to draw is, which is already in the PowerPoint, but let me draw here. A ladder is inclined to the wall. Ladder is inclined to the wall. Okay. Like this. Okay. Show all the forces acting on this ladder. The ladder is in rest. This is surface 1, this is surface 2. 1 and 2 both consider both rough. Both is rough surface. Okay, you may assume the both surface is rough. By assuming both surface rough, can you show all the forces acting on this ladder? Okay, I give you a hint. There are 5 arrows, 5 forces acting on this ladder. 5 forces. I mean 5 arrows required. Like the inclined surface, you only have 3 forces, 3 arrows: friction, normal force, weight. But for this ladder, you have 5 forces. Actually, 3 types of forces. One type of force acts in 2 places. Another one type of force also acting in 2 places. So actually only 3 types of forces, but the 2 forces acting twice. Okay. So can you tell me what are the forces acting together? What force acting at the center? The weight. So weight is acting straight down. Mg. Okay. So at this point, because it's touching the wall, some force is exerted by the wall. What type of force? What type of force acting on the ladder caused by the wall at this point?
Frictional force.
Very good. Frictional force. Frictional force acting up or down at this point?
Up.
Up. Good. Because the ladder tend to fall down. So it opposes movement. So should know frictional force acting up. Good. Then there is another one force acting on this wall again. The wall not only give friction upwards, the wall also, because the ladder presses the wall, so the wall going to push it back. With what force? With normal reaction. So you have a normal reaction here. Okay. So friction up, normal reaction horizontal, it's actually 90 degrees. Okay. So now same thing happens to this surface. What are the force here? Friction. Friction acting to the left or to the right? Friction acting to the, because the ruler the ladle tend to move to the right. So friction holding it from, preventing it from moving to the right, right? So friction is to the left. Correct? Friction, because the ladder tend to move to the right one. If it's what do you call it, frictionless surface, it's going to move down, move to the right. So friction holding it. Any other force acting? Because the the ladder presses the floor, so floor going to give reaction. So normal reaction acting up. Good. So this is your normal reaction. Okay, these are the force acting on the ladder. 5 forces. Okay, friction, normal, and weight acting down. Okay, so you should know how to identify what are the forces acting on this ladder. Okay, so now I go to these are the 2 images you have to draw and that empty slot. Okay, in this empty slot, you have to draw the inclined surface and this ladder. Ladder, you don't need to draw the triangle. These 5 forces is enough. Okay, so please draw that in this document. Draw the vector diagram for the forces below, the triangle, the inclined surface and the ladder. Okay. Okay, now go to the PowerPoint. Okay, good. So just now this ladder I discussed, there is some differences here. What is the difference? Just now I show you 5 forces. Okay, just now I show you 5 forces, but here they show only 3 forces. What happened? The floor was rough. The floor was rough, but according to this diagram, the wall is smooth. It's a smooth surface. Okay, so what's the difference? Smooth surface. So smooth surface means, of course, no friction lah, no friction. So let's come to the rough surface first. Rough surface, what are the force acting here? Normal force acting up, then friction acting where? To the right or to the left? To the left, friction. Okay. These are the 2 arrows they're supposed to draw. But what happens sometimes, the 2 forces here, they merge, the friction and the normal force, they merge to give one single vector as a reaction. That's why in this diagram only have reaction this way. It's actually, this reaction is actually the resultant force have normal and the frictional. Okay, sometimes they do that. Okay, they merge these 2 forces. Okay, so normal force is up and friction is this way, so the resultant will be this way lah, the resultant, so they call it this your reaction force. Okay, now come to the smooth surface. Smooth surface means what force is absent? No friction. I mean the only force acting here is which force? The normal reaction, only the normal reaction. So because it don't have friction upwards, so the only force is normal reaction. That's why they put a horizontal line. This is exactly, the reaction is actually exactly the normal force. Yeah, exactly the normal force. And the third is of course, the weight acting down. Yeah, the weight acting down. What they are trying to do here is they want to try to draw the triangle. If you want to draw a triangle, how this triangle looks like? The weight acting down, then the normal reaction, the second one is this way, horizontally, it's 90 degrees. This is your weight. This is your reaction 1. I put here 1, R1. So therefore, this is your R2. So R2 must be diagonal here. So yeah, just to make a triangle, they simplify the 4 forces into 3. The 2 forces have been merged. Okay, any question from this diagram? This is different from I did earlier. Earlier one both rough. Okay, this one wall is smooth. floor is rough. Okay. If sometimes they can ask, floor is smooth, wall is rough, and then how is it going to be? Floor is smooth, let's say. Okay. So it's inclined. If the floor is smooth means, of course, no friction here. You only have a reaction force up. But wall is rough means you will have a friction and also the normal force. So finally, you get the resultant here somewhere like this R, like an R, and of course weight acting down, weight acting down. So 3 type of ladder inclined to the wall circulating. You please check. Is it both rough? Is it floor rough? Or is it the wall rough? 3 of them have a different type of force diagram. Okay. Okay, any questions so far? Understand, Okay. There is another one indication which I believe you never realized before. If the system is in equilibrium, okay, let me up this. Normal reaction. I already told you it's friction and a normal reaction. Makes the reaction. Okay, these 3 forces. Okay, yeah. Okay. If it's in equilibrium, another one thing, the 3 forces acting on this object, if you extend the forces, this force you extend, and this force also you extend, both forces extend the line of action, they'll meet up at a single point. They have to meet up in a common point. If all 3 forces meet up at a common point, this is the indication that they are in equilibrium. Okay, something new for you. Okay, so how to indicate? Weight is acting down. The weight is acting down, but you prolong the line of weight. Line of action, you just prolong it up. The reaction force, you just prolong the line of action here. And this reaction also, you prolong the line of action here. So all the 3 forces, the line of action must meet up at one single point. Then we say this system is in equilibrium. Okay, something new. Okay, for example, you see, they say the flagpole here is in equilibrium. That means weight acting down, you prolong the line of the weight up, and the reaction here is acting this way, and the tension is acting this way, all going to meet up at a single point. Then we say the pole is in equilibrium. Okay. But in reality, can you tell me at this point, how many forces are acting at this point? Finally, create this reaction. The normal reaction and what? The friction. Friction acting where? Up or down?
Up.
Friction acting up. So in your mind, you must be careful. There is 2 force, friction and normal acting here. These 2 forces have been merged to become a single force reaction. Yeah, they can merge it. They want to make a triangle. That's why they try to make it to 3 forces. Okay. Okay, yeah. So this is the flagpole diagram. It's in equilibrium. Okay. So the weight acting down, the reaction acting like this way, and the tension added. Okay, it must make a closed triangle. Tension, weight, and the reaction. Okay, let's make a closed triangle. Okay. So this. Okay, now what is the answer for this? Identify the forces in equilibrium. Out of these 4 answers, which is in equilibrium? So the force must follow one after another, right? So the answer should be
D.
D. So D is the answer, of course. Because the force, the head of the first vector connects to the tail of the second vector. So it's connected. So it's in equilibrium. Okay. Identify the forces in equilibrium. Which one is in equilibrium? Can be more than one answer. So this is one follow one after another. No. Is this follow one after another? Also no. This follow one after another, the arrow. Yes, this is correct. And this also follow one after another. It's like in one circle. So of course R and S is in equilibrium. Okay. What is the condition to be in equilibrium? The net force in any direction must be 0. What is the consequence the body say to be in equilibrium? Two consequences you can have. It must be in rest or move with constant velocity. Don't say constant speed, constant velocity. Another consequence, can be in rest or move with constant velocity. Also say to be equilibrium. Okay. I believe you learned this before. Just emphasize again. I recall back. Okay, now your turn. Please get the working for this question, the diagram. And so you should find the FA and FB. Okay, class, get me the working. Get me two equations. Find the FA and FB if the light is in equilibrium. So first, I think the best, you can draw triangle. Can you draw the vector triangle first? How the 1960 FB, FA going to make a triangle? Make sure you place the 60 degrees at a correct corner. At which corner it makes 60 degrees. Once you make the triangle, I think you should be able to find the two answers here. So if this is 60 degrees means, yeah, this is 60 degrees means here it's going to be like 60, right? It's going to be 60 here. Okay. This is 90, yeah. Okay. Which force you take to draw first? Don't ever start with the diagonal one. Don't start with the FA. I think I prefer I take the vertical one because we know the value. So I draw 1960 first, going down. At the tip here, I join the FB. FB must be here. Because the lamp and the FB here must take 90 degrees. Then FA just going to close up the triangle. We can close up because it's in equilibrium. So it's your FA. So where's your 60? 60 is, where's your 60? 160 or 260? 1 or 260? Anyone? 1 or 260? 2, because this is FB going like this, FB going like this, and FA is like this. FA we can draw here, FA here. So this is the angle, This angle is actually same as 60 lah, 60. So 2 is 60. This is 60, and this is 30. Okay, good. Okay, so those who got this triangle, that means correct. Now from this triangle, you can find these two answers. By using what? Of course, trigo. Use trigonometry. Find your FA. Maybe use 30 degrees. You want to find FA, use cos or sine, 30 degrees. Or you can take 60. You take 60 lah, 60. 60. Opposite over hypotenuse is what? Sine, right? So sine 60 is equals to what? Sine 60 equals to FA over not FA, opposite over hypotenuse. So 196 over FA. So you can find FA. You can find FA. You get 2263. So FA is actually what? FA equals to 1960 divided by sine 60. Yeah, sine 60. Yes. So you should get this answer. Okay. Sorry, define FB. Cos. You can go for cos. You can go Pythagoras now because FA also, you know. It's up to you. So if you go cos 60, then what happened? Cos 60. Yeah, sorry, it's not cos 60. Tangent, right? Opposite over opposite. What do you call? Yeah. Opposite to the adjacent, right? Okay. So you use tangent now, tangent. So tangent 60 is equals to what? 196 over FB. So you solve this, you should get FB answer. Okay, so most important here is you can't do this question if you can't figure out this triangle. If this triangle you're unable to figure out this triangle, then difficult for you to find the answer. Okay, so the important is the triangle. How do you draw this vector triangle? Follow one after another. Start drawing with the vertical arrow or the horizontal arrow first. Diagonal, put it as the last. And make sure the internal angle was positioned correctly. Okay. Any question from here? So I hope you understand. Okay, so that's the working should be for this question. Okay, so we proceed with the equilibrium. More questions. We go to the next question. Okay, look at the diagram. The point A is said to be in equilibrium. Okay, the point A is in equilibrium. The container weight is 736. The container weighs 736. That means the weight acting down is 736 Newton. What is the tension TAB and TAC? What is the tension AC and AB? Okay, tell me. We are focusing to point A. The tension AC acting diagonally upwards or diagonally downwards? Tension AC. Diagonally upwards or downwards, the tension. We are focusing to the point A. Point A, the tension here is up or down? Up. The tension AC is upwards. For the point A, the tension is upwards, pulling it. Okay. Like you are standing here, you are like the person, your hand is tight. Your hand experiences tension upwards, pulling up. Okay. Here, this tension also upwards, tension AB. Angle here 50, angle here 30 degrees. So this angle should be how much? Or this is 90, oh 100, sorry. This angle is how much? 100. Yeah, 50, 100, 30, 180 watt. Okay, good, 100. Okay, find the TAB and TAC. Okay, it's up to you. You want to draw a triangle? You can draw a triangle. Or is there any other way to find the TAB and TAC without drawing triangle? Is there any other way? There is another one way to find the two tension here. What is another way? Resolve all the forces to their components. See, the total force upwards, must be equal to the total force downwards, right? Because if it's in equilibrium, total force to the right, must be equal to the total force to the left. This is another way of finding the tension. Okay. So instead of drawing the triangle in this case, what is the force acting upward? The total force acting upward. The TAC and TAB is the one contribute force upward. What is the force contributed by the TAC upward? How much is the angle here? How much is the angle here? Here 30 degrees. Here 60 degrees. So what is the vertical component of TAC upwards? TAC, the force upwards, contributing upwards. The force upwards contributed by who? The TAC, the vertical component of the TAC and the vertical component of the TAB, upwards. So what is the vertical component of TAC upward? Yeah. TAC cos 60 or sin 60? You close the 60 or you open the 60? TAC from side, you bringing up. So you close 60 or open 60? You like close. You close the 60. So use cos or sine. Yes. You close the angle. Use what? Use cos. So it will be cos 60. So force upward will be cos 60. Okay. AC lah. Cos 60. Okay. AC is cos 60. Okay. Or can you use the 30? Can you use the 30 here? If you use the 30, TAC you go up, you can use this cos 60 or use what? Or you can use TAC sin what? Sin 30. Okay. Either use this or you can use this. That's the vertical component of TAC. But in the working, they put TAC sin 60. Okay. So they use 60 degrees, they find the vertical component of TAC. So TAC sin 60, they use TAC sin 60. Sin 30, sorry, sin 30. Okay, you can use cos 60 also, I get the same answer. Okay. So what is the vertical component of TAB upwards? So TAB sin 50. Sin 50. So these are the two forces acting upwards, force up. Okay. Because it's in equilibrium, force up must be equals to force down. Force down is 736. So you get the first equation. So TAC sin 30 plus TAB sin 50 is 736 Newton. First equation. You can't afford to solve TAC and TAB because two are unknown. Therefore, you need another equation. So how you can get another equation? By giving force to the right same as force to the left. Okay, who contribute force to the right? The TAC. Resolve down. The TAC resolve down, that is the force acting to the right. Is it weight contribute any force to the right? Is it 736, is it contribute any force to the right? No, 736 because it's acting vertically down. It never exert force to the right or to the left. The force to the right is caused by TAC. So TAC, when you go down, 30 degrees you close, TAC cos 30. This force to the right. Force to the left will be what? Who contribute force to the left? The TAB. And TAB resolve down, you close the 50, so TAB cos 50 is to the left. So TAB cos 50 is used. So TAC cos 30 to the right must be same as TAB cos 50. So this is the second equation. So after that is maths. Two equations, use simultaneous equation. You should be able to get these two answers. Okay. So this is another way of doing your what do you call finding the forces. Instead of drawing the triangle, you can break them. Force up equals force down, force right equals to force left. You can get two equations and you get the answer. Okay. Any clarification required for this question? Do you understand what I'm saying? Can hope you can follow. So this is how you need to find the forces law, equilibrium. Okay, so as we do some questions about this, okay, go back to the question. Question is focused about equilibrium now. Okay. Okay, this question. This is Juno 2, questions 15, page 2, page 2. Okay, body equilibrium. Get me the answer 15. What's the answer? The vector diagram shows 3 coplanar forces. Coplanar means the forces acting in the same plane, like the table is the same plane. All forces acting parallel to the table. No force acting like moving upwards. One force moving out of the table. One is like surface is not coplanar. Coplanar means all forces in the same plane. Okay, two-dimensional. Okay, the magnitude of the resultant force of these 3 forces is 1 Newton. What is the direction of the resultant force? Can WhatsApp me the answer? Okay, so one said C, one of you said C. Is it C? Okay, another one said D. D or C? One said C, one said D. C or D? 4 Newton acting down. I think these 3 and 4 you can merge. Merge these 3 and 4. 3 and 4 you merge, what happened? Then you can get the answer. Okay, so what I'm trying to say, 4 Newton acting down, just leave it. Okay, the 3 and 4 you merge. 3 up here and 4 you merge, become 5 here, right? Right, 4, 3 up. So the 3 and 4 merge is actually 5, right? So 3 and 4 we merge, make it 5. So up is 5, down is 4. So resultant is 1 Newton, which direction? Diagonally upwards. So answer is cos D. Yes, so D is the answer. Okay, cannot be C. Because 3 and 4 makes a 5 Newton force upwards. So 5 up, 4 down, so finally 1 Newton upwards, diagonally. So D should be the answer. Okay, understand? Can okay, class. So done for today. Okay. As a homework, what I want you to do is, of course, this paper. The notes. Try to answer these 3 questions which we already discussed. Okay, 3 answers, write it in this paper. There is empty slot. Write it out. So next class we'll be discussing with the center of gravity and the turning effect. Okay. Any questions before I stop? So what you learned today's class? Type of forces and equilibrium. Okay. What the 3 type of forces you need to know? The friction, viscous force. Then another one is what? Friction, viscous force. Another one, what I told you, upthrust. Okay, upthrust is one of the most important forces. Upthrust, can I say upthrust oppose movement? Oh, I didn't ask this. Is it upthrust oppose movement? No, upthrust just act upwards. That's it. It does not oppose movement. You just want the object to move upwards. That's all. Okay, friction and viscous oppose movement. Well, so with this, I stop. So I see you tomorrow. Tomorrow we'll be continuing with this topic. Okay. Okay. So yeah, done. Thanks. Any questions? No questions. Okay. So I stop here.